Hi everyone, today we're going to be solving AQA GCSE Chemistry Higher Tier Paper 1. In this video, we are solving June 2021. This is a part 1 of the video where we're going to be solving from question number 1 to question number 5. This question is about carbon and its compounds. Fullerenes are molecules of carbon atoms. The first fullerene to be discovered are Buckminster fullerene. What shape is Buckminster fullerene molecule? So Buckminster fullerene is circular, all right? So we can say it's spherical. Give one use of fullerene. Fullerene can be used for drug delivery around the body, hydrogen storage, antioxidants, to deliver antioxidants, to reduce bacterial growth. Fullerene can be used as a catalyst. Cylindrical fullerene can be used for strengthening materials, as spherical fullerenes can be used as a lubricant. Guys, any one of this particular point will be a good answer. Just write only 1 point for your answer. Propanone is a compound of carbon, hydrogen, and oxygen. Figure 1 shows the Rauch diagram for a propanone molecule. Complete figure 2 to show a propanone molecule. Use a line to represent each single bond. Okay, guys. Propanone is made from 3 carbon. So we're going to draw the 3 carbons. And all of the carbon has 4 bonds. The middle carbon already has 4 bonds. So the rest of the bonds are going to be hydrogen. Guys, when drawing this one, we can take help from this particular diagram. However, I just did it on my own, but you will take help from that particular diagram to mention the hydrogen and the carbon. Determine the molecular formula of propanol. So we can see the molecular formula of propanol is 3 carbon. There is 6 hydrogen involved, okay, and 1 oxygen. So C3H6O will be the molecular formula. Propanol is a liquid with a low boiling point. Why does propanol have low boiling point? Boiling point is a property that is decided by intermolecular forces. So propanol must have weak intermolecular force. So the intermolecular forces are weak. This will be the reason. Figure 3 represents the structure of a graphite. We can see each layer of graphene. They are stacked on top of one another to produce the graphite. Explain why graphite is a good electrical conductor. It is soft and slippery. You should answer in terms of structure and bonding. So in this particular diagram, guys, we will be looking at, so what do we see is we see each carbon is covalently bonded with 3 other carbons. So since they are covalently bonded with 3 other carbons, all right, each carbon has 1 delocalized electron, 1 electron that didn't bond with anyone. That electron will be able to move within the structure and thereby carry electrical charge. So graphite, this is how, this allows graphite to conduct electricity. Because the graphite is a layered structure, and the layered structure, each layer is like a, interlocking hexagonal rings, they have very weak intermolecular forces between each layer, which is what makes them, this weak intermolecular force between them makes them slippery. They can slide over one top of another, which makes them soft and slippery. So the answer should be as follows. This question is about atomic structure and the periodic table. Gallium is an element that has 2 isotopes. Give the meaning of isotopes. You should answer in terms of subatomic particles. Isotopes are atoms of the same element with the same proton number but different mass number or different number of neutrons.
Table 1 shows the mass, numbers, and percentage abundances of the isotopes of gallium.
Calculate the relative atomic mass AR of gallium. So if we are trying to find out the AR of gallium, so we can find out the AR of gallium by multiplying their mass number with their percentage abundance and the second mass number with that percentage abundance. And then we will divide it by 100.
And this will give us our final answer, which is 69.8. Our answer is to answer up until 1 decimal place. So we can write the whole thing. Gallium is in group 3 of the modern periodic table. Give the number of electrons and neutrons in an atom of gallium isotope. So the number of electrons will be equal to the number of protons. So this will also be the number of electrons. So 31. And the number of neutrons will be 69 minus 31, 38. What is the most likely formula of gallium ion? Because gallium belongs to group 3 of the periodic table, so it should be Ga3+. Gallium was discovered 6 years after Mendeleev published his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev periodic table become accepted.
So Mendeleev already predicted the missing elements in his periodic table, he predicted that, that those elements, when they will be invented, that they will have this kind of similar properties, similar to that of the particular group that Mendeleev has put that particular element in. So when this gallium was, discovered, then it fitted that gap the Mendeleev has left. Gallium properties were already predicted correctly by Mendeleev. This question is about the extraction of metals. Element R is extracted from its oxide by reduction with hydrogen. The equation for the reaction is hydrogen reacting with RO3, R is produced along with water. So hydrogen is more reactive than element R. The sum of the relative formula mass Mr is 150. Calculate the relative atomic mass Ar of R. To calculate the mass Ar of R, we will first of all multiply 3 times hydrogen. Each hydrogen is 1, but there are 2 hydrogens, so we'll multiply that by 2. We don't know the Ar of R, but we know the relative atomic mass of oxygen. So that will be 16 times 3. So this is equals to 150. Now we're going to make R the subject, and then we're going to take all of these on the other side. So 150 minus 48 minus 6. So this gives us 96. Identify element R. You should use your answer to question number 3.1 and the periodic table. So we already found out it to be 96. And when we see the periodic table, we find that the identity of R is molybdenum. Carbon is used to extract tin from tin oxide. The equation is shown here. Tin oxide reacting with carbon to produce tin and carbon dioxide. Calculate the percentage atom economy for extracting tin in this reaction. Relative atomic masses, AR. In order to find out the total atom economy, first of all, we need the MR of reactants. So reactants are SnO2, which is 119 plus 16 times 2, plus our reactant is carbon, which is 12. So total mass of the reactant is 163. Percentage atom economy. Our total reactant is 163, and our desired product is 119 times 100. This gives us a 73%. Tungsten is a metal. Tungsten is extracted from tungsten oxide, WO3. In other solid products from the extraction method must be separated from tungsten. Table 2 shows information about 3 possible methods to extract tungsten from tungsten oxide. We can use carbon. The cost is very low. However, it produces tungsten carbide, which is a solid and hard to separate. We can use hydrogen. The cost is relatively high. However, we only get pure tungsten solid and water vapor, which can escape. We can use iron. The cost is relatively low. We get tungsten solid and iron oxide solid. The problem is iron oxide solid will be difficult to separate. Evaluate the 3 possible methods for extracting tungsten oxide from tungsten oxide. The points that I have already told you will be the ones that can be written as answers. So I will give you a final answer. Carbon and iron are the cheapest reactant, but separating solid products is expensive and also time consuming. So this is why hydrogen, even though it is the most expensive reactant, since it only produces water vapor as a byproduct and no separation of solid is needed afterwards, can be a better process. This question is about group 1 elements. Give to observation you could make when a small piece of potassium is added to water. So when we add a small piece of potassium to water, we are going to see the potassium will float because it is lighter than water. The potassium will melt because it is reacting with water and the reaction is very exothermic. And the potassium will move around, alright, because the reaction will produce a lot of gases and the gases will cause the potassium to, jump around. Alright, potassium becomes smaller and eventually the potassium will catch fire. Alright, it will catch a flame and the flame color will be lilac. And because we are producing a lot of hydrogen, so we will also see effervescence. Complete the equation for the reaction between potassium with water. So potassium can react with water to produce potassium hydroxide and hydrogen. Now, you will notice that this equation is not balanced. In order to balance this particular equation, we will count the number of hydrogens on the right-hand side. On the right-hand side, we can see there are a total of 3 hydrogens, but the left-hand side has only 2. So if we put a 2 in front of the potassium hydroxide, we're going to have 4 hydrogens. So we will put a 2 in front of the water. This makes 2 oxygen, which is also matched here. However, this makes 2 potassium, which we need to balance over here. Explain why the reactivity of element changes down the group 1. We know that down the group 1, the reactivity increases. All right. The main reason is group 1 elements only has one outer shell electron. As we go down the periodic table in group 1, the atoms become larger and larger, and their outer shell electron is farthest away from their nucleus. So it becomes increasingly easy for them to lose that outer shell electron because they have very less attraction with that outer shell electron, because that outer shell electron is very far away. And then the atom loses the electron very easily. Because group 1 element needs to lose that electron in order to do reaction, this makes them very reactive. So the answer can be written like this. Sodium reacts with oxygen to produce the ionic compound sodium oxide. Oxygen is a group 6 element. Draw a dot and cross diagram to show what happens when the atoms of sodium and oxygen react to produce sodium oxide. So at first, we're going to be drawing a sodium atom. Sodium has electronic configuration of 2, 8, 1, whereas oxygen has an electronic configuration of 2, 6. So sodium will require 3 shells, and second shell will have 8 electrons in sodium, and the third shell will have only 1 electron. We will need 2 sodiums and 1 oxygen. So we'll need to draw the sodium back again. Okay, now the oxygen's part. Okay, so for the oxygen, I'm drawing with the red. The first shell has 2 electrons. The second shell has 6 electrons. So the second shell is in a shortage of, shortage of 2 electrons. These 2 electrons will be provided by sodium. Oh guys, I'm supposed to draw a dot and cross diagram. So these are crosses. So this will produce sodium without the outer shell electron. So we're going to remove the outer shell electron, and this will cause this particular sodium to be positively charged. And for the oxygen, we're going to have two electrons in the first shell, and in the second shell, now we're going to have 8 electrons, out of which 2 electrons were given by sodium. So this will give it 2 minus charge. Why is oxygen described as being reduced in the reaction between sodium and oxygen? So oxygen gains electron. So gain of electron is reduction. Explain why sodium oxide has high melting point. Sodium oxide is basically, it's a giant structure. All right. So it gives, because it has a giant structure, all right, there will be a strong electrostatic force of attraction between the oppositely charged ions. And if we want to break that strong electrostatic force of attraction, we're going to need lots of energy to break that strong electrostatic force of attraction. And as a result, high amount of energy is needed to break that bond. This question is about salts. Name the salt produced by neutralization of hydrochloric acid with potassium hydroxide. So a salt produced from hydrochloric acid will be chloride, and a salt produced from potassium hydroxide will have the potassium name in front of it. So potassium chloride. Write an ionic equation for the neutralization of hydrochloric acid with potassium hydroxide. Guys, we need to remember the ionic equation for a neutralization reaction is always H plus ion with OH minus ion to produce water. Soluble salts can be produced by reacting dihydrochloric acid with an insoluble solid. Copper, copper carbonate, copper oxide, and are insoluble solids. Which of these insoluble solids can be used to make copper salt by reacting with dilute hydrochloric acid? First of all, copper does not react with dilute acids. Okay, so the next options are either copper carbonate or copper oxide. So copper carbonate and copper oxide should be the answer. Any answer that has copper in it should be already cancelled. A student makes crystals of magnesium sulfate. The student uses this method. Add sulfuric acid to a beaker, warm the sulfuric acid, add a spatula of magnesium oxide to the beaker. Stir the mixture. Repeat the steps 3 to 4 until the magnesium oxide remaining in the beaker. This is to ensure that all the acids are reacted. If the magnesium oxide, since it is insoluble, we can put it in excess. And if there is no acid, the magnesium oxide will not react. Filter the mixture. So after that, the reaction mixture is filtered. Evaporate the filtrate gently until crystals start to form. Leave the solution to finish crystallize. Give one reason for step 2. Okay, so step 2, warm the sulfuric acid. We want to give it activation energy so that the reaction is speed up. All right, so we can generally write to speed up the reaction. Step 5, repeat steps 3 and 4 until there is a magnesium oxide remaining in the beaker. So as I already told you, this is to make sure the hydrochloric acid, all of the hydrochloric acid reacts. For step 6, filter the mixture. So, we are filtering the mixture to remove the excess magnesium oxide from the solution. so that we can have pure solution, which we can then crystallize. How should the filtrate be evaporated gently in step 7? So whenever we have the steps for evaporating gently, we must do this particular process on top of a boiling water bath. So we can use boiling water bath. Iron chloride is produced by heating iron in chlorine gas. Iron plus chlorine, FeCl3. Calculate the volume of chlorine needed to react with 14 grams of iron. The number of moles of iron used, the number of moles of chlorine that react with 14 grams of iron, the volume of chlorine needed. Okay, so these are the calculations we need to do. Okay, first of all, the number of moles of iron used. Number of moles Fe. We will divide the 14 with 56, which is the air of Fe. Our answer will be 0.25 moles. Now we will find out moles for chlorine. Now this is what we need to react. So we can see that iron is reacting in a 2:3 ratio. So whatever number of moles for iron we have received, we will divide it by 2 and we will then multiply it by 3 to get the number of moles of chlorine, which is 0.375 moles. And then we're going to calculate volume for chlorine. So volume of Cl2 equals to 0.375. And since each mole of gas is 24 dm³ per mole, so we will, 0.375 mole times 24 dm³ per mole. So the mole and mole cancels each other and the multiplication gives us volume in dm³. So 9 dm³. Guys, we are done with question number 5. Thank you for joining this particular video. And guys, I'm located in Dubai near DIP Metro. If you are in the surrounding area and you are looking for home tuitions, please let me know, all right, in the comments. Ask for my email and definitely I'll give it to you and we can then contact and we can continue. All right. Guys, thank you for watching the video. Best of luck for your exam. See you in the next video. Bye-bye.